law. You should know it. Hello, welcome to Chaos and Controls, the show where we talk about modern devices, technology, and techniques for automating your home, business, or life. I'm your host, the Automation Doctor. Today, I thought we should talk about one of the more fundamental tools in any electrician's toolkit, certainly if you're an automaton, something you should know, Ohm's Law. Now, Ohm's Law states that voltage is equal to current multiplied by resistance. That's it. That's the law. That's the video. You can all go home. Thanks for watching. We will catch you next time. Alright, well, maybe we'll elaborate on that just a little bit more. Ohm's Law, as it turns out, is probably the most fundamental equation in all of electrical engineering. If you're an electrician, an automaton, heck, even most mechanical engineers probably know Ohm's Law. And it comes up in a surprising number of situations where most of the mechanics in the field that I've worked with anyway at least have a functional understanding of how it should all work, but often enough people just don't have a strong grip on electricity, I suspect because it's difficult to see. In any case, Ohm's Law really helps drive forward the three most fundamental concepts in electricity, namely voltage, which is said to be the potential. And some people think of high voltage as being dangerous and low voltage as being okay, and there's a little bit of tracking there, but a more accurate way to think of voltage is the potential to do something. If I have more volts, I have more motivation to move electricity through a wire. Current is honestly what ends up getting you. You can have a 1 million volt taser and hit somebody with it, and they'll get up afterward and be fine or shook up a little bit. It only takes about a quarter of an amp to put somebody down, and an amp is the measurement of current or the flow of charge through something, and anything that resists the flow of charge is resistance that we measure in ohms. And these are the three most fundamental concepts in all of electrical engineering. Voltage, which is your potential, current, which is your flow of charge, and resistance, which is what resists the flow of that charge. Now, if you get deep into the nitty-gritty and start looking through the Maxwell's equations from which all of electrical theory is derived, the math and the physics, and it all gets really kind of hairy fast, and frankly, I'm just not all that good at it, even at my level of schooling. That said, by refining the units down to get us to volts and amps and ohms, Ohm's Law is so spectacular because it has these three fundamental concepts, and they are so easily related with one another. And so let's do a couple of examples for where you might want to use Ohm's Law just to get an idea of something that's going on out in the field. Now, on this channel, you're going to hear me refer to 24 volts a lot because it's a very common industrial controls control voltage. So let's, for a moment, assume that I have a 24-volt power supply, and I am running it through a load that is the equivalent of 24 ohms of resistance. And so V is equal to IR. In other words, 24 volts is equal to some unknown current multiplied by 24 ohms. We can do the math and find that the current, I, going through that particular circuit is 1 amp. In another example, let's use 12 volts, which is common in vehicles. Why 12 volts? Good question. I don't know. In any case, let's assume that I have my 12-volt battery in, say, a truck, and I'm going to run it through my headlights that have, say, 3 ohms of resistance. 12 is equal to my unknown current multiplied by 3 ohms. If we do the math, we'll find that I have 4 amps worth of current. Now, I know that can sound a little bit terrifying, particularly after I just told you that somewhere in the ballpark of a quarter amp is enough to put somebody down permanently, But consider the following. Your body also has a fair amount of resistance. And even in the worst case scenario, you typically have somewhere in the ballpark of about 1,000 ohms between any 2 points going across your heart, even when wet. And so when we do the math with 1,000 ohms, what you will find is that if a quarter amp is the limit, somewhere in the ballpark of 250 volts is where we really need to be concerned about accidentally touching something and ending our life, which hopefully helps explain why when you accidentally touch 120 volts in, say, your house, it really hurts, and yet most people are able to get up and walk away from that. On the other hand, most houses also have 240 volts-ish for the dryer, and so I don't recommend sticking your tongue on it. In any case, it gives you a rough ballpark for worst-case scenario of what a quote-unquote safe voltage would be, but most control voltages, as I said, we're going to be dealing with 24 volts predominantly on this channel, all the way down to even 3.3 volts that things like the Arduino are really well known for. In any case, hopefully you can see some of the examples of where Ohm's law can come into play and where you might want to apply it to understand how much current do I have going through a particular device. Am I in danger if I touch this thing? And, current ideas, because current, as it turns out, is really the predominant factor in a lot of things, whether it's how much my wire itself it can take. For instance, the gauge of the wire will tell you how much current is allowed to flow through it before it's in trouble. And so Ohm's law is very applicable in a lot of different situations. Hopefully you get something from this. Either way, I will catch you next time.